All right, everybody. Good morning and good afternoon, as the case may be, and thank you for attending this PowerCast. 3 ways to protect the IBM from ransomware with Joe Herdvik and Mel Zucker of Software Engineering of America. This PowerCast is sponsored by SEA. My name is Ian Curran. I'm Education Manager for Common. And if you experience any technical issues during the presentation, go ahead and send me a chat message and I will address your issue. If you'd like to send a written question to Joe or Mel during the presentation, for that, you're going to use the Q&A area and they will answer your questions at the end of the presentation as time permits. Presenting today are Joe Herdvik and Mel Zucker. Joe has worked with IBM and its predecessor systems since the dawn of the AS400 in 1989. He has managed IBM hardware and network systems for several Fortune 500 and private companies for the last 20 plus years. Mel is a 30-year IBM veteran. He worked in AS400 and IBM customer engineering, program support, system engineering, and technical consulting. For the last 15 years, Mel has served as the lead technical support resource for SEA's internal and external customers. With that, I'm just going to ask Joe to go ahead and take us away. Joe, go ahead.
Good afternoon, everyone. Welcome to the webinar. Let's do a word or two about SEA before we get started. SEA has been in business since 1982. They provide IBM security, monitoring, and automation solutions. And their big thing that they like about SEA and what they really thrive on and very proud of is that they offer 24/7 by 365 support, and that there's always someone available to answer your calls. A little later on, we'll be looking at their anti-ransomware product, which is part of their iSecurity suite of security solutions for the IBM. And that will be part of the webinar towards the end. But first, we are going to go in and talk about ransomware on the IBM today. We're going to start with what is ransomware? I know it's basic, but just to define some basic terminology here. How does ransomware affect your IBM and your IBM files? What is we want to present as we're going through here is a three-way approach. It's a layered approach to protecting the IBM from ransomware attacks that you might want to consider for your shop. Then we're going to get into the thorny issue of, okay, let's say you get hit with ransomware. What do? Do you pay the ransom? Do you recover your files? If you recover your files from media, what are the best practices for recovery? And then we'll talk about using IBM solutions for isolating and preventing ransomware attacks. Start at the beginning. Ransomware is basically a category of malware that encrypts objects and devices on the computer it's running on and on other computers that it's connected to. Once the files are encrypted, the ransomware creator will usually demand a payment to restore your files. And we'll talk about how that comes in a minute or so. And there's a secondary threat with ransomware, in that the ransomware creator may also take a copy of your files before he encrypts them or they encrypt them, and then threaten to make your data available on the internet, which also will result in another ransomware demand. The question becomes, is the IBM vulnerable to ransomware? Well, the answer is yes and no. The IBM OS itself isn't able to run the PC executable files that ransomware runs on. So in that regard, you can't run ransomware on your IBM operating system itself. But there is an exception where IBM is vulnerable to ransomware that we'll talk about later in the presentation. The big place where the IBM is vulnerable to ransomware is in the integrated file system, which is, your basic file structure where all the files and folders and operating systems that run on the IBM machine, on your power system under IBM are stored. Think of it as like think of the IFS as like a PC hard drive where it has folders and directories and files underneath it. The IFS itself is vulnerable to ransomware through mapped file shares and network file system exports. So this is a nice graphic that SEA put together that tells you how ransomware works on the IBM. So basically what happens is you have a user with a PC or a laptop sitting here on the network. as part of their configuration, they are mapped through file servers and shared network drives to a file server sitting on a Windows machine or on a Linux machine or another operating system. They can also, through IBM Net Server, map one of their PC drives, like any of the drive letters from A through Z, like R, S, Q, T, to a file folder sitting on the IBM IFS. And that's done through Net Server. So the user is sitting here working on their system. They're connected to network drives. They're connected to IFS folders. If they hit on a connected device, a malicious email, or an attachment that contains ransomware, that can corrupt their machine and start a ransomware executable, which will then go out to its mapped network drives, both in Windows and on the IFS, encrypt the data on any drive where they have write and executable access, close those files, delete the original file, and rename it, and leave a set of ransomware instructions on your IFS, which will be usually that they expect you to pay them in Bitcoin to get the decryption key so that you can do the reverse project and unencrypt and rename the files back to their original format. Now, practically speaking, what happens and how does it affect your IBM I processing when folders and files in the IFS get encrypted and renamed? Well, the first thing that happens is disabled IBM I apps that rely on stream files in the IFS will no longer work. Java is a good example. Any Unix apps that you run under PACE may no longer work because their executables and other support files are stored in the IFS. If you're running your IBM I as a web server or storing HTML files there, they may get encrypted and no longer work either. Open source applications, another good example, very much IFS based. Scripts, faxing, all of these applications or any application that either runs within IBM I OS or uses PACE or any other technique may stop running if their IFS folders are encrypted and renamed. It can also corrupt IFS-based data. A lot of people may use the IFS to store their database. Think in terms of something like an HR time tracking system or a door lock system for badge readers. Also think in terms of things that files that may be stored there may be updates. You may have things that you communicate with another computer and download to your IBM I so that you can update their tax files and things like that. They can be encrypted and renamed. If people are using, or if you're using the IFS as a file server, any user documents or company documents stored on the IFS, including like spreadsheets, Word docs, graphics, can be renamed. Then there's also the threat of exposing company information, as we talked about, where before encryption and renaming, the attacker may take a copy of your folders and threaten to publish it. And then the last thing that can happen is it could also make your IFS a ransomware source, where in addition to encrypting and renaming files, it can store another time release ransomware executable that's just waiting for someone to click on it to start the ransomware process again. So the IFS can actually be an IFS and a ransomware victim and a ransomware source. Now, we talked a little bit about how ransomware breaks into your business, but let's go over this again because this is important. 70 to 90% of ransomware and virus attacks happen through social engineering techniques. Someone sends your users an email that has a deceptive URL. The URL may be for Google, but instead of O's in the name google.com, it uses zeros. It may be phishing. Someone may call your users and bait them to click on a certain website while pretending to be someone in your HR department or one of your executives. Opening an email attachment or an attachment on the network is very common. 70 to 90% of the attacks come from social engineered attacks. The other 20 to 40 come from unpatched and unsupported software. For example, Microsoft Windows. Every second Tuesday of the month, they download patches to update their server and their desktop software. A lot of those patches are security patches. If companies wait, several months before applying all the latest security patches, it could increase the vulnerability of getting attacked by ransomware. Old PCs, this is a big one. I worked for a company one time that had a badge reader system that had to run on a Windows XP machine. Can't do too much about it, but the problem is if I have that old PC running on my network and it can find a way to get to my IBM IFS or other things, it can get infected with ransomware. Windows XP, Windows 2008 R2, there's still servers out there running that. Windows 2012. Older, unpatched, and unsupported software is generally about 20 to 40% of your ransomware. Now, we talked a little bit before about there's basically three ways. There's basically three ways that you can protect your IBM from ransomware. And we also talked about this as a layered approach to protecting it. Here's some things that you want to consider in doing a layered approach. There are three ways to protect your IBM to ransomware. You can, consider protecting it from the outside. Since most of the ransomware attacks come from outside the IBM, if you protect the network, you can protect your IBM IFS. From the inside, you configure your IBM to minimize ransomware exposure, mostly through what security settings you give your users and how you configure your IFS shares. And then the third way is to use a third-party anti-ransomware software package. Those packages run on the IBM. Those packages run on the IBM, and a lot of them, as Mel will show you in a few minutes, can detect and isolate ransomware attacks as they happen and cut off the source. Okay, protecting your IBM from the outside. Remember, I had said that one of the strategies and one of the things you need to do is make sure that the machines that connect to your IBM and to map drives on the IFS are protected, because all ransomware attacks for IBM always start somewhere else. At one point I was a network manager where I was in charge of the entire network and the IBM itself. And one of the things that I always made sure to do is that every machine on that network was supposed to have anti-malware software that includes anti-ransomware protection. That's one of the things you can do, is the clients who are going to map to the IFS and may have authority to read and write and delete files on the IFS should have anti-malware software on the machines that includes anti-ransomware protection. One of the things that you can do. One of the other things we would suggest you consider is user education on social engineering scams, so that your users will recognize when they're encountering a phishing scam. A lot of companies during their onboarding process give computer training. Part of the computer training is safe computing. Learn how to recognize social engineering. That's something you can add to your user onboarding or your user training, so that your users can be on the lookout and at least have an understanding of when something looks fishy and they should call the IT department, or they should just not click on something. The other thing you want to do is determine what your organization's recovery ransomware plan is. If you were like me and you were doing the network and the IBM, you might be the person in charge of it. If you're just doing IBM security from ransomware, consider, working with your network people, see what they're doing to stop ransomware, use that as a basis and come up with your own IBM recovery plan. Because what I would suggest you do, or what you want to consider, is if the ransomware attack is in progress, it may be too late. You might want to think about what you're going to do before your machine gets attacked with ransomware. Okay, what IBMI techniques help reduce the risk of ransomware? Here are a number of things you can check on your IBMI, and we would urge you to consider looking at these and making decisions on how to handle these particular items that are best for your company and fit in with your own ransomware recovery plan. First thing you want to look at is observing basic IBMI security. And your auditors will tell you this, left and right, other people will tell you this, but this is just basic security for your IBMI. Limit, consider if you can, limit the number of all objects and SecAdmin users, because any of these users who have all object authority or SecAdmin authority, when they map a drive to your IFS, can potentially infect that drive with ransomware. Look at your user groups. We may have a user from Bob from accounting, for example, who has no special authorities, but he may belong to a new user group that has SecOffer authority. Look at your user groups. One of the things you want to consider is what authorities do my users obtain through the user groups, and should those authorities be changed? Then, of course, there's the standard keep your IBMI OS, operating system PTFs, group PTFs, and technology refreshes up to date, especially your security updates. Now, what I would urge you to do and what I would urge you to consider is I'm going to show you a number of configurations you could look at on your system. Examine those configurations, see if they fit your company profile and your company needs. And then if you need to, make some changes. I can't make any outright recommendations, but I can tell you where the problems are and where things are you might want to look at to reduce your ransomware exposure area. First off, IBM recommends that you not share the qsys.lib folder or the root folders of the IFS. What it is the qsys.lib is the folder under which all your IBM OS objects reside. All of your libraries, your data, your user profiles, everything else. Remember I said there was one exception to where IBM OS is vulnerable to ransomware? The exception is if an all object use, and it doesn't occur very often, but we have heard some reports of this. If someone has very weak security and they have a user who has all object authority that's mapped to a file share pointing to the qsys.lib library, they could potentially damage IBM objects because all of those objects will be under that file share. So IBM's recommendation is not to share qsys.lib. And the same thing with the root folder in your IFS. Everything on your system resides under the root folder in the IFS. If there is a net server file share that points to root, and you have a user with the authority to change, delete, write files to the IFS, they could potentially encrypt and rename any file or folder under the root directory. So it's not a good idea to share qsys.lib folder or the root folders. There is one particular authority list, and you can check this on your own machines, and I'd urge you to consider looking at this and making whatever changes you are needed, called QPWF server. It's an authority list that IBM put there to put additional security restrictions on users accessing the qsys.lib folder through a file share, through a remote client. So it's users who are accessing qsys.lib through a remote client. You can put additional security, you can specify additional security restrictions there, and there may be some security restrictions you need to tighten up. For example, I believe one of the default settings in that authority list is for Star Public to have use authority to qsys.lib. So review that, determine if it's appropriate for your company, and make whatever changes you need to make for your own security. Another couple of ways to reduce your ransomware exposure area: control access to your file shares. If you've got a file share that's only needed by 3 people, don't include the entire company in the authorization list on that file share. So, take a look and see who actually needs to get to this particular IFS mapping, and make your shares read only as appropriate, so that when, for one example that I'll give is I used to work for a roofing company, and we had to keep warranties for at least 30 years after the roof was put on, because those roofs last a long time. So we had a folder out there where they could look up their warranty information. Well, for the general users who aren't going to be updating warranty information, you could give them a share that's read only, and then ransomware wouldn't be able to encrypt those files. And then maybe make another share that's read write. So the recommendation is, or the consideration here, you want to look at your file shares, only include necessary users, and as appropriate, you think about making them read only. And you also only want to map shares as required. And like I said, when I had my dual net hat, where I was network manager and IBMI administrator, one of the things that I had control over was PC provisioning and Windows AD user mappings. Avoid putting IFS drive mappings in your default PC configurations or your Windows AD setups. That's one of the things that you might want to consider. And there's a lot of reasons you may want to, but it gets down to the point of only give access to the users that are needed, and don't map drives more than you need to. Map the drives only as needed, and this will reduce your exposure. Another way to reduce your exposure is, you think about it, look at every once in a while, go in there and inventory your file shares that are no longer needed, and make a decision if you want to remove them. There sometimes file shares that are mapped through NetServer multiply. Sometimes a programmer or manager may put in a file share for a one-time use and it never gets removed. Take a look at what you have as far as file shares and see if there's anything extra. You can inventory those through IBMI Navigator or through the Go Nets menu. Also consider, take a look and see if and what's appropriate for your guest user access. Guest user access to NetServer is what NetServer will use when you try to map a network drive to an IFS folder and the person doing the mapping doesn't have a valid IBMI user profile. It's basically anonymous, mapping it as an anonymous user. Well, you may have a good reason for that, and it may fit in with your company needs, but just take a look and review what authorities your guest user profile should have. There's also a couple of other file systems on the IBMI that do also allow mapping to the IFS, one of which is Network File System, NFS. Take a look at the settings for those systems too, and make whatever changes you feel are appropriate. Okay, another way to reduce your IFS and file share ransomware exposure area: mount points. For example, when I take out NetServer and I say I want to put a network drive pointing to this folder right here, and let's assume that's the warranty folder that I talked about. I want to put that network, I want to make that IFS file share that users will use to map their network drives point only to this folder. I don't want to point that file share to the top of the IFS or any folder that's above the folder I want the users to need. You should avoid creating a file share above, because you want to make your file share mount points generally as explicit and as far down the IFS directory as possible. So, when you're getting ready to map file shares, consider mapping it to the lowest level, just like you do security on least privileges. This would be mapping file shares on least privileges. Do it on the lowest level possible to minimize your exposure. Okay, when you actually get ransomware, and we don't make any recommendations as to what approach you should use to cure your system of ransomware or to restore your system back to normal, but choose whatever option works best for you. But generally, there's two ways that you can cure your system of ransomware. So if you have an IFS folder or folders where the objects are encrypted and renamed, your two options right at the moment for taking care of it is to pay the ransomware. That's not recommended by the FBI, but in a lot of situations, like we saw with the ransomware attacks over the summer, companies have to do it anyway just to keep going. And some companies even consider it a cost of business. So that if you pay the ransomware, understand that, pay the ransomware to get a decryption key, which will, unencrypt your files and rename them. Understand, though, that there's some risk coming along with that. For example, where's this decryption key coming from? Are you paying it's like paying a bank robber to give you your money back. So you're getting a decryption key. Where is it coming from? Does it work? That's a big one. There's been a lot of reports out, or there's been reports out there that sometime when ransomware hits a company, they get a decryption key and it doesn't work. Does your decryption key include bonus ransomware? Are they going to, as they decrypt your files, put another file out there that later on can be accessed and restart the ransomware cycle? So you may have, there may be some good situation. Consider your situation for paying the ransomware, but there are some risk involved too. But the other option is to restore the encrypted renamed files back into your IFS, which has a few risks as well. We'll talk about those as well. Okay, one of the things we talk about, and people will say, it's probably, consider backing up your IFS every night. And as important as the backups is the retention schedule for how long you keep an IFS backup after it's backed up. Because what happens a lot of times is you may not discover the corruption for a couple of days, and you may need to go back to a couple of days, or, God forbid, you may have to go back a couple of weeks to restore the files. So what we're talking about here, and just giving you as an example, and do what works for your shop, or think about or consider what works for your shop. This is a 7-6-12 retention schedule for the IFS backup, where, in a shop, if I were running a shop today, I might think about retaining my IFS backups for 7 days, so that anytime within the last week, I could go back and restore files. And one of those backups may be a full system backup. Then the weekly backups I may keep for 6 weeks, so that I could go back within the last month and restore files if something went wrong. And my monthly backups I might keep for 12 months. So, if something really goes wrong and I have to go back up to a year, then I could do it. So that'd be my 7-6-12 retention schedule for IFS backups. The other important thing, and if you're covered under Sarbanes-Oxley, if you're covered under PCI DSS, you can't restore what you don't have. I've talked about how you need to be consistent with your backup, and I bring up SOX and PCI DSS for a simple reason, in that both of them have requirements to test to make sure your recovery procedures work. You don't want to be in a situation where some of your IFS objects got taken out and were encrypted and renamed, and you go for the backup tape and find there was an error in your backup routine and it didn't save the IFS after all. As you do this, and a lot of the auditing and some of the, as we said, some of the auditing requirements, regulations will tell you, you have to prove your backups work. And one of the ways that we've done it in the past, or I've done it at some of my shops, is as I'm backing up, I'll back up a dummy folder on the IFS. My backup routine will delete that folder, and then I'll restore that folder just to prove that I can restore from that IFS backup tape. So, oops. Okay. Let's do a word about high availability backups and ransomware. If you have an HA system, a lot of times organizations will use the HA system to back up their production data. And the reasoning is simple. I have my production machine is working over here. I have an exact copy of all my data and programs on my HA machine. I don't have to take down production. I can just back up HA. And that's common for people with HA machines. What you have to remember, though, is that your HA machine usually resides in a different subnet in a geographically distant location from your production machine. And there's a possibility that it could also catch ransomware, and some of the IFS folders on that machine could get corrupted. So in addition to monitoring your production system for ransomware, consider monitoring your HA systems for ransomware as well. And not only HA, if you've got a development system, if you've got a QA system, if you've got a user test system, just, take a look at those and monitor them for ransomware as well. The other issue that you're going to get into, which, is just the nature of replication, is if someone in my production system gets a ransomware attack and takes out an IFS folder on production, and that folder is replicated, those encrypted, deleted, encrypted, and renamed files will replicate over or will propagate over to my HA system. So I'll have corruption on both systems. So consider that, and consider the effect of ransomware on other systems, most notably high availability systems. Okay, so that's basically the layer where you can protect try to protect your IBMI to make it more ransomware resistant rather than ransomware proof. You won't be able to stop everything, but there are some things that, consider all of those things I talked about. And, take a look at those things and consider how to implement those, or if you want to implement those in your shop. Mostly your IFS protections. Now, what we're going to go into here is there is software that you can get for the IBMI that will help you detect and isolate ransomware activity as it's attacking your IFS. The first is there are third-party systems. SEA offers iSecurity anti-ransomware that will do just that, and Mel is going to demonstrate that in a minute. If you're not running message monitoring, a message monitoring system might find some kind of situation inside your company, like, for example, an object gets renamed that shouldn't be renamed. Message monitoring can help alert you, do early alerting when an IFS attack happens. Object auditing, exit point monitoring, where you have software that, basically looks for intrusions on your system and brings up exit point programming to handle those intrusions. Encryption. Now, it's kind of odd for me to be talking about encryption when I'm talking about battling a threat that will encrypt your IFS files. But the benefit here and the way that encryption can help reduce risk is that, remember, way back, the second ransomware threat is that the attackers will take a copy of your data and threaten to publish it. They're less likely to be able to publish or do harm if your IFS data is encrypted with a package like PGP. Again, it's one of those things you might want to consider for your system, but encryption can help in that regard of protecting your data if it's exposed on the internet. And of course, antivirus programs. Antivirus goes hand in hand with anti-ransomware because antivirus will also corrupt and rename files as well. Okay, with that, I'm going to hand it over to Mel Zucker right now, who's going to show you iSecurity, show you how a product like iSecurity anti-ransomware detects and isolates random attacks. So let's look at how this product works. So Mel, it's over to you.
Okay, thank you, Joe. And that was a lot of great information that you presented about ransomware, as well as about the IFS. So hopefully now we should be seeing my screen, a 5250 session in blue. So this would be the main menu for the iSecurity anti-ransomware product. We'll take a quick review of some of the menu options, relate them to the important points Joe was highlighting in his presentation. Afterwards, we will try to show you a demonstration of how it will actually stop a live ransomware attack. So ransomware, Joe was explaining, does not run or be executed on the IFS or the IBM. It runs from a remote device, a PC, a server. So therefore, you can't scan anything on the IFS looking for this like you would maybe a virus file. So how do you determine that there is activity occurring that is encrypting your files? Well, you have to watch for the activity itself. Number 3 is a dashboard of some of that activity. So we look for indicators. What would be maybe an indicator? Joe had a slide up briefly in the beginning that talked about a ransomware attack would typically access a network communication connection to a drive. It would open up a production file, begin reading it. It will create a dummy file or a test file. And this ransomware product will be reading the data from production and writing it out in an encrypted format to the new file. So you want to look for things like this. Also at the end, it's going to delete your production file and rename the test file to your production file name. Now, all of a sudden, all your applications are going to stop working. So you may not know encryption is occurring because your files are still intact, but they're being copied and the data encrypted to new files. And near the end, the ransomware people will delete your production files. So you have to look for activities. So we look for maybe 4 types of these activities. And doesn't have to be against a single file, just 4 of these things within 30 seconds. And we go, yay, this is very suspicious. This is definitely a ransomware attack in our opinion. Other times it's a little more subtle. Maybe it takes 9 of these symptoms of activity within 30 seconds before we say this is beginning to look like it's a ransomware, and so on. So we basically are looking for the tracks of what is this application, or in a rare case, even what this user is doing to identify there is some ransomware activity going on. We need to do something. And you notice we have the column, I want to react. So how do we react? You want automated reaction. The product has that with the ability to send a message to QSysOpera. That's important. Send a message to a SIM. Maybe you have a syslog or something. Send an email to a distribution list or to a person like an admin. But most importantly, if you suspect so much as a ransomware attack, disconnect that remote device. Do not allow that IP address to continue to have active access to the IBM. Some people have gone on and said, I've been down this road before. I'm not going to just disconnect that one device. until I straighten this out and verify whether it's a real attack or not, I'm going to end the file server to everybody. Haven't seen anybody but 1 or 2 people would take that extreme approach, but it is available for you. Typically, you want to disconnect the device that was detected, even if it's an intelligent device where it reassigns itself a new IP address when it loses connectivity. We will again detect the activity coming from that new device IP address. So we do have a couple of things that we do in addition to detecting the attack and disconnecting that. We have what we call honeypots. A honeypot is like a decoy. A decoy says, I'm going to have something out there that is, in the case of an automated application, it's going to be very low in the alphabetical sorting sequence. Because if it's a batch program that's doing its ransomware, they're going to probably go in sorting sequence. So if I just take a look at my root directory, as Joe wisely says, never share, you might see, and this is named for demonstration purposes. So we have 4 A's and then sales honey. Typically, I would not have the word honey at the end of it. Somebody might be suspicious that it is a honeypot, but nothing more than it's 4 A's, the word sales, and in it are some dummy files. If people start opening these files, nobody has any reason to ever go here and open these files. They shouldn't read them. They shouldn't copy them. They shouldn't delete them. There's no reason for anybody to ever touch these files. So it's a decoy, it's a honeypot, and it's very, very low in the alphabetical sorting scheme to try to divert an attack from your production files to these test files. So hopefully none of your data will be encrypted. So Joe talked very importantly about backups and restores. Well, what if you back up at first thing at dawn this morning and lunchtime you have some of your files encrypted? Now you've lost a half a day or a day's worth of data. So what we've also included in the product is a recycle bin. You're familiar with recycle bins from Apple and from Microsoft. I love the Apple recycle bin. When put things in there, little flames shoot out of it. At least it used to on the old Apples. But here we have a recycle bin. You can see that we have been deleting a few objects, running some test ransomware attacks and such. So we have the ability to keep an object. This is not in place of your backups. This may or may not be before or after the encryption. Hopefully it is before the encryption. So we do keep a copy of files provided they were deleted by a remote device. We don't expect batch jobs and 5250 interactive sessions to be part of a ransomware scheme. We will not put in a recycle bin daily maintenance of applications like that, but a remote device will keep here. And you get in configuring the product how many days you want to keep the data in this recycle bin. So you could say every day there'll be a job on the job scheduler, purge from the recycle bin those entries older than X number of days. Typically, we're seeing people go with 2 or 3 days. They're expecting to find out that they have files being encrypted and under a ransomware attack fairly quickly. They expect people to report their application stopped working, they're having problems, and they'll know early on about encryption. So we do have the recycle bin. So we do also provide the ability to simulate the attack. And we'll be doing this very shortly. So we do even give you the instructions. You may encrypt a test directory, emphasis on test directory, people. This is very dangerous. If you map a drive to the wrong path, if you do this wrong, this is encryption. You will decrypt your own production files. So I'm going to do this for you here to show you how this process will work. But we do also give you instructions. We give you directions for downloading a shareware encryption product and so on. So you'll be able to run your own tests, hopefully on a test folder, maybe even on a test system to see how all of this works. Okay, so that is basically the ransomware product from the main menu. We do have logs and reports. It's labeled. It is really an internal journal. Our log is a journal. So if I was, let's go back to 07/01/21. This is one of our newer test machines. We don't have a lot of data on this one compared to some of the other systems. So here you can see it works like a journal. This is not Q audit journal, but it works like a journal. I can have entries made so I can see who the user was, what was the program in the library. So I can tell you this was part of our ransomware encryption tests. And we have our own audit type that is in our journal receiver, and it shows you the job that was active. So this will be our types of logging that we have, in addition to messages to QSysOpera and such. We talked about one last thing on the menu. We talked about if we detect or suspect a ransomware attack, we are going to disable that device. Menu option 11 shows you the different testings and demos I've been doing this past week or two. And if this line was highlighted or reversed imaged, that would be an active attack. That device is disconnected. That IP address cannot connect to the IBMI. Once you identify, oops, this was a false attack. We've run into that 2 or 3 times, not too often, but we have run into it where you get a false indicator. And you just have to come in here, remove this active attack notice, and that device will again be able to connect. So how do you get a false alert? A false alert is usually from a programmer or an admin doing some maintenance. You'll be in the IFS, they'll be cleaning up and deleting a bunch of files, they'll be copying in some new files. Typical maintenance work like that can often simulate ransomware, the same types of steps of reading files, creating files, deleting files, copying files. So it can simulate it. So that is probably one of the biggest things that we have. I've seen I've seen somebody had an application where they had a scanner, an old-fashioned scanner, and they were scanning in paper documents, and the application they were running was to put it to the IFS, and then within a few seconds, copy it from the IFS to another network mapped drive on another device. Something about PC disks are cheaper than IBM disks, I think was the logic behind that. And just the process of you scan it in, you create the file, you read the file, you copy the data to a map drive. It just simulated some of these things that said, this is suspicious activity. This is not a normal business application. So what do you do if you have things like maybe your application does this, or you have a user that has to come in and do cleanups? We do have the ability to have exclusions. So if the occasion occurs where you are running into a false alert, you may come in and you may tell the product, do not monitor this directory for ransomware activity. And basically, you can do all sorts of wildcards. Maybe it's only certain object types that this cleanup or maintenance is done with, or maybe it's the entire directory and so on. So you do have the ability to exclude directories. And that so far has eliminated the few false alerts that we have been running into. So I'm going to be dealing with a DOS prompt in order to show you the ransomware attack. So I'm going to bring up my DOS screen here. And I have my ransomware installed in a directory. Razlee, who is the developers of the iSecurity suite of products. And I'm going to open up a little Word document. If any of you have ever worked with me in a GoToMeeting, you know how well I type. So I'm going to just basically map a drive in DOS. I'll just copy and paste this mapping. So here I'm going to map a drive. You can certainly use Windows and map a drive that way. And I will put in my user ID and my password. And I am now mapping the drive. I can do a dir of a colon, and this is now coming through the VPN and showing us our test directory, apt test. So I map specifically to my test directory with this share. I did not share the root or anything like that. So now I could enter the program name for that encryption application. This is just open source, readily available on the internet. Maybe some of you have heard about WannaCry. It was one of the original encryption products out there that was doing a lot of damage. I cannot type and talk at the same time. Sorry about that. So I will just run the WannaCry example. And what this old version does is it's actually going to copy the data, encrypt it to new files, and it's going to want to rename these encrypted files with a suffix. Instead of .com or .exe, it's going to put in .wcry. Some of these original ransomware programmers, like some of the original virus programmers, they would like to sign their work, their signatures, and it was very easy to detect it. Now they stopped doing that, so it's a little bit harder to detect it. It's not just a matter of looking for a strange or unknown extension, but that still is one way. So if we run the test is going to come up and says, do you want to stop after you encrypt one file, or do you want to keep encrypting all the files that you can? And seeing as this is a small directory, we're going to simulate a real ransomware attack, and we're going to say, encrypt as many files as you can. So it's going to go out over the internet and get a certificate, temporary certificate. It's going to create a log file. This is the shareware application that's now running, and it's running over the map drive A to my IBM I. So we begin to see it is now attacking the first file in that folder, which is one of the PDFs. And this will take a minute. We might see some other activity coming, and we'll just let the encryption run its pace, run its course. So what's probably happening now is the detection, the product detected this is very suspicious and disconnected the drive, and there was a 2-3 second TCP timeout. You notice the messages we're getting in our log, this file survived, this file survived. So we have all of these that survived the attack. If I scroll back up, since this is a known one, an old WannaCry encryption, it probably encrypts very few. Actually, it's excellent. This new version encrypt none. So no files got encrypted, but this is a very old ransomware. So if I come back over here to my green screen, I had an encryption. I can do a display message, qsysopper, and here is a ransomware attack has occurred. You can monitor for this in qsysopper products such as ABS message. We tell you the user ID that was connected from the map device, and that's the device's IP address. So if I come back to DOS for a second, and I try to do that, what I did earlier when we started, dir a colon, I can see my a colon. So here we can see that we have this encrypted. If I come in with option 11, I can see it is now highlighted. I can remove this and repeal, the effects. This was stopped attack. This device is now having access, and it is done. So we now have had the complete process. One last step for me would be in my DOS prompt. I want to come over here and I want to remove the share. So the A drive no longer exists. So you can run this test in your own test environment. Be very careful with your mapping, that you map to the correct location. You don't want to map to the root. You don't want to map to a production type of directory. So earlier during the meeting, during the presentation, there was some questions I saw coming in. If I can minimize my Word document, maybe I can find those questions, or I can impose upon Ian to read them to me. Here's some questions. Oh, a lot more came in. So Ian, do you want to read the questions, or should I take the few that I already see?
Go ahead and take the few that you see, but not everybody is seeing it. So read the question before you give the answer.
Good tip, thank you. So how do we know which day of IFS restore is required? Well, once you've encrypted this, it goes back to your old IBM technology and experience. And a little bit of what we talked about, what Joe talked about, is how this works. Hopefully you have Q audit journal. Maybe you even have some audit logging of your more critical business files. So that way, if Q audit journal will show you a date and a time and an entry when a file, a critical business file, was renamed or deleted, that will be a great way. The message is, if you have a product like anti-ransomware, the message is from QSysAPA says, we detected this today. And if we're a good product, which we think we are, it doesn't mean that this happened yesterday, unless yesterday might have been before you installed our product. So you should be able to get a message from QSysAPA. Q audit journal is another good way. You might have some sort of firewall application. iSecurity Firewall is under the suite of products. So we have that available. So
all right, let me say that if you do have questions, put it in the Q&A panel now. We have a couple minutes left if you do have questions. Mel, if you have another one that you want to answer, go ahead.
Okay. Let me scroll down here. We have daily incremental save lives. Okay. How can we find a good backup without ransomware? This is going to come right down to, as we've been talking about, your good IT practices about monitoring when it occurred. Be sure you're auditing some of your critical files in the IFS, not just your library files. We do have our own custom journal where we do our own logging. This option 41 logs and report is our own journal. And this is just for the IFS that we're monitoring. We monitor the IFS for encryptions, as Joe was indicating. Library objects we're not. So I've been scrolling, but did I miss any of these, Ian? I scrolled through a lot of them.
I don't think you have. I have a couple that were sent to me directly. Before I read them, though, if you do have a question, now is the time to do it. Use the Q&A panel on the bottom of the frame and select to send to all presenters. This question is, what kind of performance issues do you see when running an anti-ransomware program?
Oh, that's a great question. You're always concerned about that. So far, zero, none. We had a couple of instances where people installed the product. They were doing a proof of concept and they thought it was. So we got together and we disabled the product, and it turned out it was a runaway application. So cross our fingers. So far, so good. It's been a couple of years now that we've had the product out, and really have not run into it being a performance issue. Now, I suppose you could have a busy enough IFS in some businesses where it might, but so far, no.
All right, again, Q&A panel, select to send to all panelists, and Joe and Mel will answer your questions. Now, I will say that people have been asking about a replay from today. Yes, this session is being recorded. I'm going to post it to the Common Learning Management System overnight. It'll be available from tomorrow, and everybody will get an email once it's ready. All right, this next question is, can you exclude IFS directories and folders on the IFS?
Well, it's important. It comes in mostly about false alerts. We talked about this a little bit if somebody was late or maybe they went to refill their coffee cup. But option 6 gives you the ability to set out either objects or directories themselves, or paths, subdirectories as well, that you don't want the product to be monitoring. The few times we've used this, it had to be with situations where we had people getting false alerts due to administrators or more often programmers doing some cleanup and maintenance in their own personal folders.
All right. So this will be the last question. Do you monitor QTemp or the TMP IFS? Do you
the QTemp or IFS, we do monitor the all the directories in the IFS. So yes,
QTemp wouldn't really come into it because that is an IBMI folder.
right. That
folder.
I'm assuming that QTemp, the person asking the question, is referring to the library, but we do monitor all of the directories. So we might see temp, TMP, TEMP, TMP, VV. You might have temp directories in your IFS. They will be monitored.
Okay, we're at the end of our hour. So thank you for your time, everybody, for joining. Again, replay and the handout will be available from tomorrow. Everybody will get an email when that's out. Joe and Mel, thank you very much.
Okay.
Thank you. Thank you, everyone.
Okay. Goodbye, everybody.
Everybody have a good day.